So part A says explain why the graph has no vertical asymptotes. So vertical asymptotes would normally be found by assessing the denominator equal to 0 and solving. Okay, so you can see here that we have x squared plus 5 equals 0. Rearranging that, we get x squared equals minus 5. Square root and minus. In this type of question, we're only after real solutions. So we could then state that therefore there are no real solutions. Another way you could do it is to use the discriminant, so use your b squared minus 4ac on x squared plus 5 to show that the discriminant would be less than 0, therefore no real solutions. The horizontal asymptote would be given by dividing the top and the bottom through by x squared, so by the highest power of x, and so on the top both those terms would tend to 0 as x tends to plus or minus infinity, and on the bottom you would have 1, so you'd end up with 0 over 1, so y would just equal 0. Right, part B says show that if the line y equals k intersects the graph, the x coordinates are the point of intersection of the line and the graph must satisfy the following equation. As soon as you see the word intersect, we're going to use simultaneous equations, so we're solving where the line y equals k intersects the graph y equals x minus 2 over x squared plus 5. So we'll set those two equal to each other, and now our task is to rearrange that to get it in the form here. So multiplying up by x squared plus 5, expanding the bracket, then taking everything to the left hand side, and then finally putting the 5k with the plus 2. You can see we end up with what we need. The next part says show that the equation has real roots if k lies within that range. So the key here is has real roots. Has real roots tells me that if we apply use the discriminant on this quadratic, the discriminant will be greater than or equal to 0. Now it doesn't say it has two distinct roots, so it can have the equals to part as well. So the first thing you're going to write down when you do one of these questions is your interpretation of the question. So in other words, you're telling the examiner that we understand what has real roots means, so we're going to write that b squared minus 4ac is greater than 0. And for some unknown reason this program doesn't have the greater than or equals to sign, so I'll have to draw it in. So that's always going to be the first mark. That gets you your original mark. You've understood what the question is. And from there you're just going to sub in your values of a, b and c, and you will see what happens. You'll end up with an inequality. We'll solve the inequality. We'll get this answer, okay? Just have to trust it and just go with it. But that has to be your first stage, what we've drawn there. Another thing I'd always do is write down your values of a, b and c, okay, just to ensure you don't make any mistakes. So I've subbed in my values. I'm going to rearrange that. I'm going to always want to try and get my k squared positive because it's easier to deal with. So if I take everything over to the right hand side, as I look at it, it'll look like my inequality sign has switched around. Now this looks pretty nasty to factorise, but there is actually a clue. If you look at what you're trying to show, the numbers on the bottom of those fractions are going to be with the k's in my bracket. So what I mean by that is because I've got a half, I'm going to have a 2k at the start of one of my brackets, and because I've got 1/10, I'm going to have a 10k at the start of one of my brackets, so that will help me factorise. Now the only way I'm going to get a -1 is a -1 and a +1, so just have to work out which way round. Well, I'm going to want to times the 10k by the +1 to enable me to get the +8. Okay, so just checking, you've got 20k squared plus 10k minus 2k would give me the 8k, and then the -1. Alright, so we're actually solving an inequality though, so we need to sketch and find the regions for which this is less than or equal to 0. So I've done a very quick sketch of the quadratic there, and that's all it needs to be. I've labelled my crossing points. So we just need to realise that we're looking for when it's less than or equal to 0. So that would be the region under here. And and you should hopefully be able to see that we're going to end up getting this, okay? Because I want when k is greater than or equal to minus a half, but less than or equal to 1/10. And again, because this program doesn't like inequalities with equal to signs, I'm just going to write it out. Okay, so we've shown that that is the case. Okay, when we look for the points where this horizontal line intersects my graph, what we're imagining is this horizontal line moving up and down. Okay, this line y equals k. So we're finding the possible values of k for which that intersects my graph. So the maximum value of k here is the highest point on my graph, and the minimum value of k is the lowest point on my graph. Thus, this is the y-coordinate of one of my stationary points. This is the y-coordinate of my other stationary point. So all you're going to do for part D is you're going to sub y is 1/10 into your initial equation and find x, and sub y equals minus a half into your initial equation and find x. Cross multiplying, so take the x squared plus 5 up and times it by the 1, and then take the 10 up to the other side, times it by the x minus 2 would give us the following. Expanding the brackets and taking everything to one side would get the following. And at this stage in the stationary point questions, you should always get the same thing. You should always get a quadratic equation that has repeated roots. And you can see for this that would work, that we'd get x minus 5, x minus 5. So if you don't get this repeated root on a question like this, then you know you've gone wrong somewhere, because there's only going to be one x value that corresponds to that y value. If there were more than one x value that corresponded to that y value, it wouldn't be a stationary point. And then repeating that process with minus a half. Okay, so finally you need to write these as coordinates. So when y was 1/10, x was 5. And when y is minus a half, x is minus 1. And they're the two coordinates of your stationary points. That is a really typical question for rational functions in FP1, and it tends to take a similar form. It might be you're showing that there is no real roots or it has a repeated root, but it generally takes that same form, so you need to learn that process, that method.